Okay, so we can use the same logic that we did with transformations to create the equation. So we're just really moving backwards. Now remember that, like, though you can, sine and cosine are the exact same shape. So um, given just a graph, you can actually model it with a sine or a cosine wave, either one. It still has the same amplitude, period, and axis. What's going to matter is the horizontal shift, and so we'll have to talk about that very specifically. The first one's the amplitude, and so or the axis. The axis is the middle of 19 and 3. So the average of 19 and 3 is 11. And so we actually have an axis. The middle line here is at 11. The amplitude is the height above the axis. Sorry, so the equation will have to have a vertical shift up 11. The amplitude is the height above the axis or below. In either case, it's 8. And so that means we'll have to have a vertical stretch by 8. So if we just have sine or cosine, they have an amplitude of 1, so they're going to need a stretch factor. And the period is the distance here. We can see it the clearest, 140 to 320. That's 180 degrees. And so that means, like, the sine or cosine have to be compressed by a factor of 2. 1 over k, which is, or 1/2. So the k value would have to be 2. So we have to have a compression by a half. Possible sine equation. So if we have a vertical stretch by a factor 8, we need an 8 on the front. Use sine. Now sine 2 will be to do a horizontal compression. Now it goes in the bracket, so there's going to be an x, but we have to have a horizontal shift. So this is the tricky part. 140 is here, and so if it's a period of 180, we saw that when we did the transformations that every key point is 45 degrees. So even though we can't read this, we know that that's actually 45 above 140. So that's 185. This is 45 above 185, and that's 45. And so this point actually down here, where the sine equation actually starts on the ground and goes up because it's y values. So this point here will be your horizontal shift number. And that's actually to the right 95, so because it's 45 before 140. This point here, you can kind of estimate it, but not that well. That's actually not quite 100. It's actually right 95. And that's actually, you have enough information to say that, because if that's 95, then 45 later will be 140, which you can clearly see that the max is 140. Then we have to have a vertical shift up 11 as well. Our cosine, cosine has to start at the top, which we already know that that's 140. So the cosine is going to have a vertical stretch the same way. It's still going to have a horizontal compression, but its shift is right 140 because it's right there. Plus 11 will be that vertical shift factor. The next one, which is a little bit easier to see, the amplitude. The axis is going to be the average of 3 and negative 13, which is negative 5. So that's the axis. So we have to have a vertical shift down 5. The amplitude is 8, so there's a vertical stretch by a factor of 8. And the period is 720. You can see that from the beginning to the end. So that means you have a vertical or horizontal stretch by a factor of 2. So the k value is 1/2. If you do 360 divided by 720, you get the k value, which is 1/2. Possible sine equation, so it has to start on 13. But now sine, you can go either way. If you start it here, you got to shift it to the left 180. So sine starts on the middle line and goes up. So it's got to be vertically stretched by a factor of 8. It has to have that 1/2 as the k value. But you can shift it to the left 180 so that you started here and you're going up. And then you have to vertically shift it down 5. So we get down 5. And you can see if you draw those lines, you can see the sine wave. Like if you look at the base graph of the sine wave, the red ones were your axis, and you ignore the scale. This is what the base graph of the sine wave technically looks like. Cosine, we can start it with 8 again. We still have 1/2. Cosine starts at the top and goes down, so This one actually doesn't need a horizontal shift. It's just x. And then we can go down 5. Okay. So just some notes, like you need to, like for sine, you need to be on the middle line going up or down. If you actually had a shift right 180 here, you could do that. Remember we had one of those questions where you start by going down. If this 8 on the front was negative. The cosine could be shifted to the right 360. I don't know why you'd want to do that, but it'd have to have a negative, so you'd be like starting on the max or the min for the cosine function. So if you want to vertically reflect it, you could shift it right 360 and have a negative here, and those would all be equivalent equations. The next one, so maybe we see that here. This one was a little bit off. I think we used 90, and it's not quite 90. So the axis is 3 because that's the middle line. We got a vertical shift up 3. That's not really that straight a line. I think I just kind of assumed that it was at 3. It's not the best graph. Just bear with me on this one. I apologize for a little bit that we're off. The amplitude's a half because we go a half above and a half below. So we have a vertical compression. And the period, this is where I'm probably wrong, is 90. And so, and you can kind of see that it is 90. It's just not perfectly at 0. That's all. What that means is it's been compressed from 360 by a quarter. And so the K value is actually 4. And so that'll show up in sine and cosine. So the sine wave, if we don't shift it to the right 45, we're actually just going down. And so we can start with a negative 0.5, and you can go down first. The sine has to have a 4x, and then it's shifted up 3. The cosine wave, if you start it down, we're actually just shifting it to the right, we'll say 22.5, right in the middle of 0 and 45. Each quadrant's compressed by 4, so if we've been compressed by 4, that's where we get the 22.5, because if you want to finish 4 quadrants in 90 degrees, everyone has to be 22.5, half of 45, and then up 3. Just note, like this example is to show you the vertical reflection, so sorry if the blue line's off a little bit, but kind of shows you the fact that like sine can start by going down, and then that way we don't do the shift, and cosine can start on the bottom. And so there's some practice.